Okay, so let's zoom in now on this particular part of the data science pipeline. Let's talk about common tools for text mining. Let me first say that text mining is again one of those fancy, fuzzy terms that I will simply use to refer to use of computational tools to extract and analyze patterns in textual data. Let me say first a couple of words about some of the common pre-processing steps that are done in the beginning of an analysis. And then let me say something about some of the common ways of then thinking about the analysis itself. So we often begin by doing tokenization, which is just a fancy way of saying that we will be splitting our text up into elements of interest for an analysis. So we'll often be splitting our text up into single words, into sentences, in the example we saw in the last video with the analysis of Chinese texts, they will probably be splitting the text up into sequences of 5 Chinese characters, of 10 characters, and so on. We might also want to remove stop words, which is to say that we might want to remove words we consider meaningless for our analysis. So for example, if we are analyzing texts that are in English and we're trying to find out what kind of topics they talk about, we might not want to be interested in how frequently they use words like and, the, of, and so on, and therefore we might want to exclude them altogether. Finally, we might also want to do what's called stemming, which means that we might want to merge words that we consider equivalent in meaning for our analysis. So again, if we are analyzing English texts to understand what topics they're talking about, we might not care about the difference between stop, stops, stopping, and so on, but rather we might want to merge them together and consider them all instances of the single word stop. When we have considered our pre-processing, then the fun begins, and then we can get our analysis proper done. Let me just say something about 4 common ways of thinking about the analysis. So the simplest thing we might do is to simply have a look at the frequency with which different words are being used, because that might be a quick and dirty way for me to understand a little bit about what a text is about. I might also want to not just look at single words, but rather look at multiple words at a time, which for some reason is called n-grams. So a bigram, for example, would be looking at 2 words that follow each other directly, but you could also be looking at 3 words, 4 words, 5 words, whatever. Just like we saw in the previous video with the Chinese text analysis, where they'll be looking at collocation within sort of buckets of 5 words or 10 words and so on. I might also want to get a little bit more fancy and try to run an automated algorithm to get my computer to uncover different topics that are being spoken about in my text, which is often referred to as topic modeling. And then finally, instead of just looking at the text itself, I might also want to join the text up with some additional information. So imagine you've got loads of texts and you have datings for those texts. You might want to do something like have a look at a trend in term frequency over time. Maybe you want to do some sort of sentiment analysis if you've got a lexicon of emotional valence of different words, and so on. The sky's the limit. Use your imagination. Let's say a little bit more about each of these 4 in turn. So again, the simplest thing you might do is simply to count words, but raw word counts themselves might be less useful than the term frequency. And the term frequency is simply calculated by taking the total number of times a word appears in a document and then dividing by the total number of words in that document. Why might we want to do that? Well, it's because imagine you've got like 10 different texts, for example, that you're interested in comparing. And so it might be that some of your texts are longer than others. So one text might have a much higher count of a particular word that you're interested in, but it could just be because that text is really long, not because it necessarily cares more about this concept than others. So therefore, calculating the term frequency can be a really useful tool for comparing different texts. Let me show you an example. So I downloaded a whole bunch of texts from the Muktaboda digital library, and then I calculated the frequency of terms that contained the sequence Shakta in them, and then I just ranked the text in terms of which had the highest frequency of that. As you can see, text 127, which is called something but Samba something. I have I have the actual title somewhere, that had the highest frequency. This could be useful information. For example, if you've got loads of different texts that you're not familiar with, and you want to know where to start to look at something manually, then knowing the frequency of particular terms that you're interested in might be a cool way to start. A slight elaboration on the term frequency is something called Tf-idf, which means something like term frequency hyphen inverse document frequency. That's a terrible name and acronym, but what this is for is that looking at the term frequency is a bit of a primitive way of trying to understand what kind of words might be important to a text. Because there could be words that are important but are not that frequent. One way to get at this is if you got multiple texts, for example. Imagine you got like 10 different texts, and imagine that one of them is about some guy with some name. And his name might not be used all that frequently in the text, but it will be used maybe perhaps only in this text, or perhaps much more frequently in this text compared to in the other texts. How could we get at this? Well, that is what Tf-idf is for. It's a way of weighting the term frequency with the frequency which it occurs in different documents. So it's a quick way of for us to get at what words might be more important in some documents compared to others. Let me show you an example. I went to Gutenberg.org, which is an open source project for interesting and important books in the public domain. And I downloaded English translations of the Mahabharata, the Ramayana, and the Upanishads. And then I did a Tf-idf analysis on single terms in these texts. And you can see, for example, that it seems that Atman is a much more important word in the Upanishads compared to the others. Pandas is much more important in Mahabharata than the others. Sorry, it's not pandas, it's pandavas. I guess there's a big difference there, and so on. Instead of just looking at single words, as I said in the beginning, or not in the beginning, but slightly earlier, you can also look at multiple words at a time, which is called n-grams. For example, you could be splitting your text up in just sequences of 2 words that follow each other directly, and then you could look at the frequency with which specific phrases of 2 words follow each other. And then you could, for example, calculate Tf-idf again, but now for 2 words. Here, I've done just that with the same text again. So you can see that Vaisampayana continued is a much more important phrase in the Mahabharata compared to the other texts. Raghu's son is an important phrase, it seems, in Ramayana. And peace is important in the Upanishads compared to the others. Of course, you could also then do other things like the kind of co-location analysis that was done in that we saw in the analysis of Chinese text, where we then would be splitting it up into, for example, sequences of 5 words, and so on and so forth. Getting fancier still, we could get our computer to run some sort of smart algorithm for doing automated topic modeling. A common algorithm for that is something that's called latent direct lect allocation, or simply LDA, which assumes that you can think about topics as a mix of words, and then in turn you can think of a document as a mix of topics. So what this algorithm can do for you is that it can go and look for try to uncover a specific number of topics within some text corpus you have, and then it can also say something about the likelihood that different documents have of including that topic. Let me show you an example. This is a wonderful example from a book that's called it's called Text Mining with R, that you can find on tidytextmining.com, that I cannot recommend highly enough. It's awesome, and we'll be using some of their tools in the next video, where they had a collection of a couple of thousand news articles from the US, where they ran a 2-topic model, LDA, on this collection. And then the algorithm went and said, okay, here's my result. I found 2 topics. The most common words in topic 1 are percent, million, new, year, billion. In topic 2, it's president, government, people, Soviet, and so on. Which seems to suggest that this algorithm here has uncovered something that looks like a financial topic and a politics topic, which, depending on kind of exactly how these news articles were assembled, might make sense, actually. You can also then ask the algorithm, okay, so what were the words that have the greatest probability of being in one topic but not the other? And there you can see, for example, that democratic is much more likely to be in one than the other, and yen is much more likely to be in one than the other, again suggesting that our algorithm here has automatically uncovered something about the difference between talking about politics and talking about economy in these news articles. These algorithms are stupid sometimes, by which I mean that sometimes the results do not make human sense, but they are interesting to play around with when you want to explore your data, and they can be particularly helpful if you're already a domain expert, so you know whether the results you get out from that are meaningful or not. Finally, I will say a little bit about the use of having additional information that we join up with our text. So I already mentioned that we might have datings of particular documents that we want to merge with our analysis in some way. You can think about this as doing what's equivalent to what Google Trends are doing. So here you can just see the sort of search activity for Shakhtar over time that you can look at when you go to trends.google.com and type in something. You can do this something that's similar to that. So imagine you got loads and loads of texts that you have datings for. Well, then it might be interesting for you to then try to plot whether how the turbo frequency of something develops in text over time. I mentioned that you might also want to do something akin to sentiment analysis. Sentiment analysis is when we try to say something automatically about the kinds of emotions or level of emotion being expressed in different texts. The way that is often done is by having some sort of lexicon of the emotional valence of different words. So for example, the Affin lexicon ranks lots of words on a scale from -5 to +5 as to whether they sort of are very negative or very positive in terms of their emotional valence. The Bing lexicon gives words a sort of binary categorization about whether they're negative or positive, and there are many other lexicons for this. Here's an example of how this might be useful, what you could do with it. Again, from Text Mining with R, where they took 2 Jane Austen novels and then split them up into chunks of 80 lines. And then for each of those 80 lines, they just calculated the ratio of positive to negative words. And then they graphed the results like this, which are quite arresting actually, because it sort of suggests that both of these novels starts out by being quite positive, then it gets really sad in the middle, and then it gets happy. It makes you happy in the end. This might be useful if there are books that you don't know whether you should bother reading. If you're wondering whether you will feel happy or sad in the end, then you could do this. But you know, it'll be super interesting. For example, to do this on Hindu studies and different texts where you can see emotional plot lines over time. But you can also think creatively about how you could do something similar by having other kinds of information than information about emotion that you could join up with your text. With that, I'm going to leave it. Look forward to the next video where we're going to get our hands dirty and then do some of these things in practice in RStudio with text from GRETIL.